Hi, my name is Bill Bliss, and I'm one of the founding members of the Microsoft Teams Engineering Group, and I am currently the platform architect for the Microsoft Teams developer platform. Today, I'm here to talk to you about the Microsoft Teams architecture, and I'll also cover some security and compliance features of the Microsoft Teams platform. So let's start with some of the principles behind the Microsoft Teams architecture. First of all, it was designed for the cloud from the very, very beginning. It was designed for what we call agility at scale. And by that we mean that it was designed so that we could add features at a rapid pace while still scaling to millions and millions of users. And last but not least, one of the original goals, and something that we still pay a lot of attention to, is to amplify the value of Office 365. Let's look at the overall high-level architecture. Let's pay attention to the color coding here, because you're going to see these colors repeated throughout the presentation. At the top, we have the Teams clients: Windows, desktop, browser, iOS, and Android. At the left is the Office 365 platform and services. The green in the middle is where you see the Teams collection of services. The orange is the Skype infrastructure. And down below at the bottom, it's all running on top of Microsoft Azure. So let's look at the clients. On the desktop, or the desktop clients, we've got web browsers, and Windows, the Windows desktop client, and then the Mac desktop client. And let's talk about the web first, because the web and the Windows and the Mac clients are all actually based on the web infrastructure under the covers. So the web client, and we support a number of browsers, of course, Microsoft Edge, IE 11, the latest version of Chrome, the latest version of Firefox, and soon, finally, is the version of Safari for the Macintosh. So on the web client, at the top of the stack is HTML5 and CSS. Below that, we talk to Angular, and we are moving to React over time. Some of the components inside the client are actually built on React today, such as the dialer, when you're the phone dialer when you use the Teams as a telephone. Below that, we have the layers of jQuery, Lodash, etc. And these are more than 200 open source components that are that we talk to. We could not have built Teams without all these open source components. And I know there's over 200 because I actually was the one who signed off on all of them. And below that is TypeScript, which compiles into JavaScript, and Node. We actually run Node on the client, and Sass for handling our style sheets. Now let's zoom in. Let's go back up here with the Windows and the Mac version. We use a project, also an open source project, called Electron, which is a way of running web applications as desktop applications on Windows and Mac. And that is shared code for both of those platforms, but the languages that we use underneath for implementing certain features are a little bit different. On Windows, it's C++, and on the Mac, it's Objective-C. And over here on the right is we have our mobile platforms. We support two of them. We have the iPad and the iPhone and iPad running on iOS, and we have Android running the Android OS. The iOS version is written in Swift, and the Android version is written in Java. And below that, we are starting to add some React Native components. And that actually is in parallel with some of the React work that we're doing over here on the web and desktop versions. Now, all of our client architecture, all of our clients are optimized for agility and for automatic updates. And by that we mean that we are actually updating the code with new features internally we actually update every single day. Externally we update every 2 weeks or every month for the web and the desktop version. A little bit less often for mobile devices. So let's look at the green boxes, the Teams services. So at the front, at the very top, we have a set of front-end servers. These are, ordinary web servers for the most part. And then there's a bunch of things down below. So for we have identity, compliance, notifications, managing teams, team management, extensibility, and configuration. So let's go through these in a little bit more detail. So The identity layers, we use AAD, Azure Active Directory, for authorization and authentication, and then we use Azure Active Directory Sync for syncing the members of Teams and Azure's version of that. For compliance, we plug into these are some code that talks to the Office 365 audit and retention functionality. And for notifications, this is the email notifications that get sent out so that you see what's going on in Outlook, or you see what's going on in Teams when you're running Outlook. For team management, these are the features that are used to create teams and channels and so forth. The extensibility functionality is also powered by a set of services for tabs, for talking to Graph, Microsoft Graph APIs, and also talking for bots. And the configuration is where all the settings associated with your tenant, there's a service associated with that. So collectively, we often refer to the team services as the middle tier. You'll hear us use that terminology occasionally, although it's really a collection of microservices. These are not one big monolithic piece of code. And the reason we do it that way is because it's more efficient for us to update, for us to code and to update, and it's less complex and all around makes it faster to iterate and deliver new features. It was also designed for scale flexibility. Each of these boxes over here have different scalability constraints and factors, and so it allows us to scale each of these services independently. As I mentioned, it gives us lower risk and higher agility when it comes to deployment. We can actually change features in one of these without worrying about destabilizing one of the other boxes. We've also optimized these for evolutionary change. Each of these boxes tends to change at a different rate. So for example, the notifications layer hasn't changed much since we originally delivered it. The configuration, the settings store changes relatively often. The teams management area, the teams area, changes a lot relative to some of the others, and the extensibility area also changes relatively often compared to some of the others. So it allows us to iterate at different paces across different services. Let's look at the orange box. This is where all the features that we use to implement the Skype functionality people associate with Skype. So it's important to know that what we're using here is the next generation version of the Skype services for messaging and voice over IP calling. This is not your father's Skype, if you will. This isn't the version of Skype that uses peer-to-peer networking. This is a brand new set of very advanced and very new web services that we're talking about here. This is where the PSTN calling, basically the service, this is what allows you to talk to the telephone network. When you have a phone number in Teams, this is what powers it. And this leverages the Skype for Business online stack. I'm going to go into a little bit more detail over here on the left in a little bit. And also presence. This is what tells you whether you're in a meeting or not, or whether you're available, etc. You see it, users see it as a set of red or green or yellow icons. The messaging stack is actually the heart of all the chat functionality in Teams. This is the one-to-one chat, which is also used for channel chat. Our media stack, this is used for seeing embedded images and video inside Teams. The search functionality is here. URL preview, that's the service that, that's the feature that when you paste in a URL, it goes out and grabs some images and a snippet of text and makes a little nice looking rectangle out of it so you can see what's on that URL. There's the service that powers that. The notification hub is what powers your activity feed. The personal expression service is what powers the emoji and things like that over there from Skype. The calling and meeting stack is very, very extensive, and this is what powers all of the calling and meeting functionality inside Teams, which is very rich and very broad and very deep. The calling service for calling another user one-on-one or one-to-many. The various transport relays. So when you are calling somebody across the world, it has to route the calls, reestablish them if they get dropped, things like that. That's a set of services for managing that. There's a media processor for encoding voice and video media in real time. There's a media controller for managing the media across meetings and so forth for across multiple users. There's a registrar service which just basically deals with registering endpoints and devices and so forth. The call recording is all done in the cloud, which is very, very different for Skype than Skype for Business. Say, when you record a meeting or a call, it gets recorded in the cloud, and there's a service for handling that. Voicemail. Trouter is a kind of an odd name. If you've ever seen Skype presentations, it'll be familiar, but other than that, it just sounds weird. But what it does is it mediates the connection of services or of endpoints that are often behind firewalls. So let's say you are on a mobile phone and you're trying to call someone who's behind the firewall running online on your network. Your device is not directly reachable on the internet, so there has to be something to make sure that connection happens, and that's what that Trouter component is. And then if there's a meeting scheduler service that is what handles it when a meeting is scheduled and when it's being established. There's the presence service, as I mentioned earlier, the lower left at people. In the middle, the config experience. That's actually an internal service, but it's what allows us to experiment with different features and different settings before we let them loose on the entire world to see which ones are more effective. There's an identity service for Skype that's used across all the Skype services, and that's also what enforces permissions to establish that people can and can't do things when they try to attempt them. Okay, let's move over to the Teams and Office 365 set of services. So, as I mentioned earlier, we wanted to really make the most of Office 365. So we strive to realize the benefits of Office 365 both as a platform, but also for its end user capabilities. And part of the vision that we have is to be an apps hub, an application hub for Office 365, and bring together all of Office 365 in one place so that you don't have to switch around from app to app. At the same time, we didn't want to reinvent the wheel. Instead, we wanted to leverage the features of other Office 365 workloads. A workload is just a fancy word for an Office 365 service. That's what we call them internally. And the way I describe it actually is we are standing on the shoulders of giants. And by giants, I mean both the Office 365 services, but also all the open source components that we use to build Teams as quickly as we did. So let's look at what we mean by Office 365 over here on the left. So if you look over here on platform, there's a set of boxes and there's a set of applications. The platform is the set of services that we sit on top of. So there's Exchange Server. We use that for a lot of things, including especially a team under the covers is an Office 365 group, which is powered by Exchange. But we also use it for email and other things. Modern Groups, as I mentioned, is actually a specific feature of Exchange. All the files in Teams, or at least the ones in Teams, are stored in SharePoint. We also have some other kinds of integration with SharePoint, but we integrate deeply with SharePoint. Stream, I mentioned earlier that when you record a meeting, you're recording it in the cloud. Well, we actually record that to Microsoft Stream, which is another service that is designed, you can kind of think of it as YouTube or Vimeo, but for your tenant. And OneDrive for Business, that's the place where when you use files for in chat, one-on-one and group chats, that your files come from OneDrive for Business. We also let you have access to all of your OneDrive for Business files directly within Teams, even if you don't intend to share them with somebody else in a chat. The information protection box is what we use for when you have rights protected things, when you want to make sure that nobody can copy or paste content. We integrate with the information protection services of Office 365. The applications are what over on the right is what you'd expect. It's OneNote, Power Apps, Planner for managing tasks and projects, but also, of course, Word, PowerPoint, and Excel. And down at the bottom, we also integrate with Microsoft Power BI for data and analytics. Remember from the architecture slide at the beginning that Microsoft Azure was at the bottom in this yellow box. So I'm not going to go through all of the boxes inside this orange box, but suffice to say we make use of a lot of Microsoft Azure, and we could not have built Teams without it. Azure is the core platform that we're built on from the server standpoint. It supports massive scale. It gives us a global footprint. It gives us redundancy and disaster recovery. And it gives us a lot of our compliance story that for Microsoft Teams. Let's look at the high-level architecture of Teams. Let's drill in one level deeper inside Teams. So this is another way of looking at Teams from kind of from a client and a services standpoint. So at the top, and most of this is familiar, is their various clients. So we've got web and the desktop version that runs on top of Electron, as I mentioned. That's basically the same code base. And we have the iOS and Android app clients as well. We've added another box here that wasn't there before, and that's the Microsoft Graph API, because in a sense, it's very much like a client. It isn't exactly, but it behaves very much like one. We often think of it as our fourth or fifth client, depending on how you count the web and desktop as one or two. So on the services side, there's a number of different boxes. Now, the point here, the key point to realize is that for the most part, there's no like single Teams layer that talks to these various services. For the most part, not always, the clients talk directly to these services at the bottom. So we've got all the other workloads, that's things like SharePoint, Word, Excel, PowerPoint, etc. OneNote is called out because it's actually what powers our Notes feature. The WAC stands for Web Application Companion, and these are the Word Excel and PowerPoint online versions of those. OneDrive for Business is what powers your personal files, and SharePoint for your team files. We mentioned earlier the experimentation server. The most recently used files is its own service in Office. We talked to that. So when you open up a file, when you want to see your recent files, that service is what provides that list. The Exchange server is what powers your calendar. It's your own personal calendar from Exchange. And we have some Teams services that talk directly to those that then is what the apps talk to. So it's kind of a mix of both direct and indirect communication between the services and the clients. The settings in Office 365 Access is collectively what we call the Team services. That was that green box we saw earlier. The messaging features, both one-on-one chat and channel messaging, is what is in this blue layer here. And the blue layer, and we mentioned earlier, the experimentation layer is this as well, is what is powered by Skype. So the purple box here is powered by Teams. The black boxes are Azure and Office 365, and the blue ones are powered by Skype. But back over here with the Teams and Presence services, that's actually what powers all of our messaging features. It's also what powers our bot features. Our calling and meeting functionality, and also the telephone network integration is also powered over here in Skype. And then some boxes over here for Azure Active Directory and Search. The chat and presence, it's kind of related to bots, but for extensibility we have connectors which are kind of like bots, but they're technically different. That's its own box over here for connectors. I mentioned earlier we had a service for notifications that powers your activity feed. Well, the way that works is that there are, every time somebody posts a message in a channel, any message anywhere in Teams, anywhere in the world for any tenant, we have to scan everything to make sure who gets notified, right? So when there is a comment, when somebody comments on a message that you posted, when somebody comments on a message that you are involved with, that you've participated in, when somebody likes one of your messages, all of those events, for every single message, we have to then figure out how to update a set of people in their activity feed. That notification hub and the Firehose listener is what powers that. So the Firehose listener is what listens to everything, and then it then farms out a set of notifications to n different users for every single message. We mentioned the stream recording service over here earlier. And then there's the email service. The email service is what powers the ability to email a channel. And this is actually the one I know a lot about because I wrote the specification for the email service. Under the covers, when you send an email to a channel, it has an email address that's been generated by this service, but the actual email, when you send it, is powered by Exchange and Exchange Online Protection. So we check for attachments, malware, and spam in the attachments. So that's all powered by the Exchange and Exchange Online Protection boxes. So one question we get a lot is, where are conversations stored? And we mentioned earlier that they're stored in the chat service. So you see over here when you're talking to Adele, when Mark is talking to Adele, you see these 3 messages and a set of other messages and so forth. Now, what you're actually seeing here is what we mentioned earlier, is the chat service. It's processed in memory for the most part for speed, but then it's also persisted in Azure storage, both blobs and Azure tables and queues, right? So when you send a message to somebody, if it has an attachment, we have to deal with that, like an image, an embedded image, and we have to know who's participating in it, and we have to make sure that the message gets there reliably. So all that happens in a set of Azure, on a set of Azure services that are on top of Azure storage. But it's also, there's some other sub-services that are involved. So the chat and channel message are also stored in Exchange for information protection and also retention and compliance. That happens over here, so they're stored there too. And conversation images, as I mentioned, and the media, if there is any, is stored in a media store. Giphies are not stored. So when you share a Giphy with somebody, that is just a URL under the covers, and then we play that back on the Giphy service. Now let's look at file storage. I've alluded to some of this already. So here's a picture of Delanda talking to Delanda, and then you're pasting a file, blog post. There's a blog post file, Word file here, and this is in the process of getting a link to this file right here. All of that's powered by Office, but the services are a little bit different. So for one-on-one and one-to-many chats, that's what you see here, one-to-N chats, the files are uploaded to OneDrive for Business, and then the permissions are set for the members of the chat. It's a little bit different for team conversations when in a channel. The files are uploaded to SharePoint, and a folder is associated with each channel in the team. When you create a channel, we create a folder at the root of what's under the covers, a SharePoint team site for that team, and then each channel has a folder in that team. And then you actually can navigate to that just like anywhere else in SharePoint using Word, Excel, and PowerPoint. Teams also supports cloud storage from third-party providers. We support 4 of them currently: Dropbox, Box, Citrix ShareFile, and Google Drive. So let's look at where data is stored. And in general, we use the term entity to say, okay, what is the thing that is being stored and where is it? And then also there's some of them, not all of them, have some things for compliance. So messages, as I mentioned, are stored in chat service table storage. All of that is moving to over time is moving to another service on Cosmos DB. It is also ingested to Exchange to enable compliance for information retention, information discovery, etc. Images, that is stored on a media service on Azure using Azure Blob Storage, and is also ingested to Exchange for compliance purposes. Files, as I mentioned, are stored in SharePoint or OneDrive for Business. Voicemail, which we haven't discussed except in passing in the past, but that is the actual files, the audio files are stored in your individual mailbox in Exchange. So when you get a voicemail and this service is enabled in Teams, the actual WAV files are stored in your mailbox in Exchange. So when you record audio and video or video, that is stored using, recorded using services on Azure and persisted using blob storage in about usually less than 24 hours. When you have a calendar meeting, that's stored in your individual calendar in Exchange. Your contacts are also stored as contacts in Exchange. And then your telemetry, which is what we use to record everything that happens in Teams across everything in your tenant worldwide. That all gets stored in a Microsoft data warehouse, and it's important to know there's no customer content in there. We strip all of that out before it's recorded. And if we do inadvertently record something, it's a bug and we fix it immediately. Usually, almost always actually, before it gets recorded, before it gets out to our public version. So this is an interesting diagram. This actually shows all the regions where data is stored across the world. As I mentioned earlier, Teams is a global service and it uses Azure's global footprint of data centers to achieve that. Now it's pretty interesting. So the map is pretty interesting. You see the 3 regions of the world, the Americas and Europe, Middle East, and Africa in purple, and then APAC, Asia Pacific. And the blue data centers, the light blue data centers, are what we say as our regional data centers. And in San Francisco and Des Moines, Iowa, and Dublin and Amsterdam and Hong Kong and Singapore were the original 6 regional data centers inside for Teams when we released. And what's interesting is that, and there's 2 of them in each region, so that if one of them goes down, it fails over to the other automatically, and vice versa. Now, the next ones, so these are our regional data centers. The dark blue ones, these are very new. These are our GCC, the U.S. government and also state and local government data centers, and those are also in Des Moines and in Virginia. The yellow ones are what we call in-country data centers, and I think our first one that we deployed was in the UK, the United Kingdom, but since then we've added them in Canada, in India, in Japan, and Australia, and we're adding more every year. And overall now, we're in 181 countries and 40 different languages, and recently, relatively recently anyway, we've added Hebrew and Arabic, which are interesting because those are right-to-left languages instead of most other languages which are left to right. So why do we do all of this stuff? So this black box, what's in this black box I'm going to explain now. So depending on where your tenant is provisioned, that determines where data gets stored. So if you provision your tenant in Australia, Canada, the European Union, India, Japan, the UK, or the USA, Microsoft stores the following data at rest within that geography: Teams chats, Teams conversations, images, voicemail, and contacts. The SharePoint Online content, that's your files, your team files, and the files stored within that site are stored there. And then all the files uploaded to OneDrive for Business. And that's the significance of, for example, that's how we achieve data residency in Canada, our in-country data centers. And Teams is also now running, as I mentioned, in the US government GCC clouds. Now it's important to know that not when you use Teams, not every single thing happens just within that data center. So this comes up, this has been asked of me before at conferences. So for example, let's say I'm in the United States and I'm calling somebody in Australia or in somewhere else in Asia Pacific. It doesn't mean that when somebody in Asia, every single byte of that phone call or that meeting has to go all the way here, or that every connection happens in the United States. That's not really how it works. Things like calls and other kind of real-time media type things happen at the closest place to where each user is. So the important thing is, and the reason we did it this way, is that we pay a particular attention to what we call data at rest. Where is the data stored? And that is where data residency comes into play, and that is where information compliance and security are most important. And that's really the significance of the data center residency in our regional data center schemes here. Okay, so let's actually cover a little bit about how Microsoft Teams guest access works. It's pretty interesting, as you probably know. The feature is designed to allow teams in your organization to collaborate with people outside your organization. And there's a number of different use cases for this, including all the way from actually having a guest in a team, but also this also covers what happens when you have a meeting or when you have an attendee of a meeting from somebody outside your company, which is extremely common, obviously. So the important thing to know is that you have one identity across Office 365. It's Azure Active Directory, we usually call it AAD, is the master for Teams identity and membership across Office 365, including Teams, SharePoint, your apps, etc. And we federate those resources for Teams chat service and documents in SharePoint Online and OneDrive, as I mentioned earlier, when you're dealing with files. Now for change notification, we have to worry about things like, we have loosely coupled services that notify each other of changes to a team. So for example, when a team is created, deleted, and updates to its members, all of those are loosely coupled services. And we want to make sure that we reflect that when you add a user to a team inside Teams, we make that update right away. We want to make that operation as fast as possible, but for that to be replicated globally across services worldwide, we have a sync process that syncs Azure Active Directory to Teams, Exchange Online, and SharePoint Online. So all of those systems are loosely coupled. So for example, you can add guest users directly via Azure Active Directory, and that goes in there, but then that gets over to Teams. Or you might add a guest user directly in Teams, and that goes through Teams and goes to Azure Active Directory. Or you might go through Azure or Office 365 groups and update things over here. And then there you also have various guest scenarios, both, as I mentioned, for guest users in a team, but also having guest users when you're using online meetings and calls for people outside your tenant. So all of this kind of at a very high level describes how we manage guest users in calling meeting scenarios and also within guest users in a team. So this is a really interesting diagram because we talk a lot about compliance and data residency and so forth. But this is actually a high-level diagram of how data flows in and out of what we call the compliance boundary. So imagine the compliance boundary is an imaginary box that is around your tenant. So when you use Microsoft Teams, you are talking to things that are both inside and outside your compliance boundary. Most of it, the important stuff, is inside. So let's actually look at these. So, and this is all color-coded. So the blue boxes represent two-way communication. The green boxes, these blue arrows actually show two-way communication. The green arrows show one-way communication, and then the lighter blue arrows show outbound. Okay, so, and what this means is that when you are talking to a standard Teams user, whether it be the browser, desktop, or mobile, when you have a guest user via Azure Active Directory, when you have an anonymous user joining a meeting, and when you are communicating between multiple tenants, across multiple tenants, you see that these data flows are staying within your compliance boundary. Okay, so even though it's two-way communication, you're staying within the compliance boundary. When you are talking to connectors or when you're emailing a channel, this is data that may come from outside your compliance boundary, but it goes into Teams, right? So no data leaves your compliance boundary when you are talking to connectors or emailing a channel, with the possible exception of configuring a connector. But the data itself from the service is one way. There is one exception to this with actionable messages, but for the most part, it's one way. So a few differences here. Let's say you use Giphy and you query to Giphy. Obviously, when the keystrokes as you're searching for a Giphy, you are sending keystrokes outside your compliance boundary. When you get a push notification on mobile, whether it be to Apple for your iOS device or Google for Android, we have to push notifications out outside the compliance boundary to those various services. If you are storing information in third-party cloud storage, Box, Dropbox, Google Drive, or Citrix File Share, then obviously the data is outside your compliance boundary because it's in those services. The URL preview service itself is inside the compliance boundary, but the data itself from the URL is not. So obviously when you have a URL to another service and you want to get data from that, you have to visit that URL and retrieve data from it and then store it inside Teams. So down at the bottom, down here below, you see a number of things from, you have tabs and applications and bots and our Graph API. So any third-party tab or the bot itself or line of business app is hosted or typically hosted outside hosted outside the compliance boundary. Meaning, the tab under the covers is just a website, a URL, or a set of URLs. Same with a bot, really, and those are hosted outside the compliance boundary. They might be inside Azure, but it's technically outside your tenant, or it's outside what we think of, what we know of as your compliance boundary. The Graph API, obviously, when you have an application that is calling Microsoft Graph, that application is hosted outside the compliance boundary. It's pulling information to and may potentially going from Microsoft Graph. When you call someone, obviously that is, or when someone calls you, that is data that is coming from outside the compliance boundary, because obviously the world's telephone network is not running inside Azure. Only the pieces of it that power your own personal telephone network, calling and meeting services. So this is kind of an overview of data flows inside and out of the compliance boundary. So let's cover security and compliance briefly. So let's go through security and privacy. And the high-level message is on security and privacy is this. So the key thing to remember with Microsoft Teams is that we have designed security in from the very, very beginning. So by that, what do I mean? Well, for one, data is encrypted at rest when it's being stored on a disk somewhere, and in transit when it's going back and forth between someone else or something else and your tenant, your users. We have dedicated security professionals. Their job is purely security 24/7 or however long they work, and we work with them every day for every single feature inside Teams. It goes through a security review. As part of that security review, performed with these security professionals, we do threat models to find out or to see, okay, where's data flowing in and out, and what if someone malicious was trying to compromise this feature, this data, how would they go about it? Where would they go about it? Where would they hit? And is it secure? These security reviews are part of that process. But we also, in addition to that, do automated security tools. Continuously, 24/7, we have tools that are running that are looking for security threats and gaps. And if they're found, then that gets reported very quickly and we fix them as quickly as possible. We have what's called penetration testing or pen testing. We have a regular rotation of third-party penetration testers. You can think of those as white hat hackers who are trying to get into Teams on a regular basis and see if they can get to your data. And we do most of this before a feature is shipped to make sure they can't, but we do it overall. And whenever anybody gets in when they shouldn't be able to, we fix that bug. So all keys are stored in Azure Key Vault. What does that mean? What that means is that there are no service has standing access, or no people have standing access to the services. So when one service needs to talk to another and it needs a password to do so, or it needs credentials to do so, there's no user that has that credential, or there's no service in a configuration file somewhere that has that configuration key or password. All of that is stored in a key vault. And keys are dynamically retrieved and restored into that key vault. So we actually use a dedicated system for doing that. It's not rocket science, but it is a best practice, and we use it religiously on Microsoft Teams. So for all of our team admins, our admins who administer our services, they have to go through security screening, particularly for our government cloud. Even more so, they get a background check by people like the FBI and so forth. We have security training and enforced access control practices. It's part of our compliance promise that we make to our customers. So on our hosts, which are all the machines or virtual machines that are powering all these services under the covers, they all have very well-defined access control, anti-malware, patch management, and we use modern authentication, AAD modern authentication for authenticating with these hosts. At the network, the edge, for example, we have robust firewalls, and we have edge routers that allow us to not only detect things like denial of service attacks, but also if things, we know where the traffic is coming from, and we can take advantage of that to make sure that everything stays safe. Facility. What that means is, as I mentioned, everything runs in Azure, and runs in a data center. You saw the map earlier. Well, the facilities, like if you were to go to Des Moines, Iowa, and to try to get to the facility where these computers are running, these facilities have physical controls, video surveillance, and access control. We want to make sure that the people who have physical access to the facilities where this data is stored are who they say they are, and that they have the right to be there. Last but not least, we have a bug bounty program, and that's another best practice. We pay people cash, whether they be friends or hackers and researchers, to find security bugs. When somebody finds a bug that puts your data at risk or your infrastructure at risk, we want to make sure that we know when those are, and so we have an incentive. We pay money for people to tell us what those are, so we can close those gaps as quickly as possible. On privacy was also built into Teams from the very beginning. It's all what we say privacy by design. So data, and you saw this earlier, data is stored in region based on tenant affinity, and that's just another way of saying what you saw in the box with the world map, is that based on who your tenant is, that's how we decide what region your data is stored in. We mentioned earlier that our telemetry didn't include any customer content. We make sure that no customer content is accessible in the logs or telemetry. While we know a great deal about what every tenant is doing at any point in time, how many messages are opened, and who clicks on what and so forth, we don't know who any of those people are. We don't know their names. We don't know the names of the teams, the text of the messages, any of that stuff. It's a black box to us. A principle, another best practice principle, is what is privilege, least privilege principle. So we want to make sure that whether it's a user or a process or a service, that it's granted the least privilege necessary, required to complete a task. We want to make sure that we don't have boxes or people that have more privileges than they need to complete a task. In addition to the dedicated security professionals, we have dedicated privacy professionals. Their job is to review privacy policy on an ongoing basis, especially for new features before they're released, but also on an ongoing basis as new aspects or angles arise, or when we hear concerns from customers. There's a whole system of Office 365 data classification standards, and we adhere to those, and sometimes we extend them as they needed. For example, when bots came along, there were no Office 365 data classification standards, so created a new one, and we reviewed it with our privacy professionals, and that's how we built our bot functionality. But that is what we use to make sure that our data handling standards and the data classification of which types of data are adhered to and respected. Access to production environments is locked down, and what that means is that it's not possible for anybody, either remotely or in person, to get to your data, even if they're physically present at the data center. GDPR, which is a regulation for how data is treated and especially how end users can handle their data inside the European Union, is what we call GDPR, and Microsoft Teams is GDPR compliant, and we have been since the deadline in May 2018. So let's look at the compliance tiers of Microsoft Teams. So let's look at it in a couple different ways. One is what we call controls, and the other one is what we call environments. So Office 365 has maps more than 950 different controls which represent laws, standards, best practices, industry standards, etc. And there are more than 950 of them. And we map those into what we call tier A, B, C, and D. And for the moment, we're only going to talk about C and D. But let's talk about the controls first. So these are things that govern, and again, things like best practices and standards around access control. Who has access to what? Both from what people have access to what, and what systems have access to what. It governs things like auditing and logging, identification and authorization, awareness and training, meaning security awareness, privacy awareness, training for all of those things. Continuity planning, and that is for things like when the power fails, when there is a disaster, when there's a thunderstorm, when there's any kind of thing that affects the data center, because things do happen, then what happens when that happens? How do things ensure that there's continuous service for Microsoft Teams and Office 365? Incident response. When something happens, what processes exist and how do people react to make sure that that incident is mitigated and fixed as quickly as possible? How is risk assessed? Communication protection is what ensures that that the communication that's happening between multiple people and is protected and is secure. Information integrity is that it's actually stored correctly and that it can be retrieved correctly. It's not corrupted in the process. Deployment approvals and management is an interesting one. This is the internal processes that we use to release features. And we want to make sure that when new code is deployed, and then how do we make sure that that code is correct, that it's ready, that it's compliant, et cetera, and how do we manage those processes? All of that is encompassed in the set of 950, almost close to 1,000 different controls and best practices in Office 365. Now, we have a set of standards that we must adhere to, but there's also a set of processes that we use to make sure, for you to be sure that we are compliant with them. It's not just, most of it is that we say that we are doing these things and we can offer proof. But we also have independent third parties come in and do audits for SOC, FedRAMP, and ISO standards, and auditing agencies come in and verify that we are compliant with those standards. Now, the environments are interesting. So, as I mentioned, I'm not going to talk about tiers B, A, and B. The key thing is that we have tier C compliance and we have tier D compliance. And D is a superset of C. You can see the privacy and security commitments, ISO standards 27001, 27018, the EU model clauses, the HIPAA standards, and SOC 1 and SOC 2. That is the minimum standard level of compliance that a service must adhere to be branded Office 365. And Microsoft Teams was Tier C compliant when we released. Tier D compliance is what's necessary to sell to U.S. government agencies, state and local governments, but also especially the federal government and the military. And there's higher levels of things that are mostly, but not entirely, covered by the FedRAMP standards. But there's also IRS standards. There's some UK regulations in there as well. And so we bundle all those up into what's called Tier D compliance. Now, over at the right is where you can download the audit reports and then Microsoft Compliance Standards, aka.ms, Microsoft Compliance Standards. Those URLs you can download the audit reports and the compliance standards that explains all this Tier C and D compliance and all the controls at a high level in more detail. I want to cover one thing quickly, which is about how Teams enables information protection. And I've alluded to information protection in a few times, both at the architectural level and back in just a second ago with some of the compliance features. So Microsoft Teams talks to the chat service, as I mentioned, And then chat service in turn talks to we call collectively the Office 365 substrate. And there's two pieces to that. One is for message related things. Email, all of your Outlook email also goes into this place. One-to-one chats, group chats, channel messages. And then your files go into SharePoint, OneNote, and Wiki, and OneDrive for Business. All of those things are stored in the SharePoint infrastructure. And on the right, you see that the Office 365 Information Protection Tools talks to that substrate. And that includes things like e-discovery and legal hold. You can do a compliance content search. You can do archive, retention, control how long information is retained, and also audit logs. When you want to see who did what when, you can do a search for those things. And all of that is stored, or rather is accessed via the security and compliance tools in Office 365, and that in turn talks to the substrate. So on the left, it shows you how it goes in the middle, it shows you where it goes, and on the right, it shows you how you can get back to it. And here are some next steps that you can take to get more information, getting up on Teams and for deployment and adoption support. And on the right, you see a number of different tools and information centers for all the way from applications to our developer documentation. Hi, I hope you've enjoyed this overview of the Microsoft Teams architecture and a little bit of a deep dive into our security and compliance functionality. My name is Bill Bliss. I'm one of the founders of the Microsoft Teams effort, and I really thank you for your use of Microsoft Teams and your commitment to Microsoft products and services. Thank you.